Let's take a look at this interesting problem. We have two sequences, one is arithmetic, one is geometric, and they both share the same final term. They're both strictly increasing in sequences of integers. We want to find each of the terms in these sequences. So let's just take a look at the geometric sequence first. So we're going to have 1, p, which is the common ratio, and so it's going to be something like this, where z equals p cubed. And next, let's look at the arithmetic sequence. It's going to be for some d, which is going to be some common difference. We're going to have 1 plus d, 1 plus 2d, and 1 plus 3d. And since these are both equal to z, we have p cubed is equal to z, which is also equal to 1 plus 3d. So p cubed is equal to 1 plus 3d. Now let's take this equation mod 3. So we get p cubed is congruent to 1 mod 3, since 3d is always going to be congruent to 0 mod 3. And so that leaves us with only one value of p that satisfies this. So p has to be congruent to 1 mod 3 as well. What's the smallest value of p that's congruent to 1 mod 3? It's 1. But we can't actually have 1 because they have to be increasing sequences of integers. And if p was 1, we just have 1, 1, 1, 1. That doesn't work. So what's the next smallest value? It's 4. So p equals 4 is the smallest. So we get 1, 4, 16, and 64. That's our value. And z is going to equal 64. Next, let's look at this sequence. We have 1, something, something, and then we have 64 again. So 1 plus 3d is 64, so 3d is 63, d is 21, so we can just add 21 to both of these, so we get 22, and this one is going to be 43. And so we want to find the sum of these 5 integers. So 4 plus 16 plus 64 plus 22 plus 43, so these two are going to be 20. 64 plus 43 is 107. And 107 plus 22 is 129, so plus 20 is 149, so our answer is E.